Hey guys, I'm Swagata and I will be one of your quantitative aptitude teachers. So today we're going to do a class on one of the basic concepts that you will face in most of your competitive law examinations like CLAT, ALET and other competitive examinations as well, where mathematics is tested. One of the fundamental concepts of mathematics is averages. This will be the first in a series of videos where we will be tackling averages and what to do with them, what kind of questions generally come in competitive exams related to averages. And today we're essentially going to explore what averages are, how the general formula of it works out, and we're going to solve a few problems and find out two different methods to solve general average problems. So without further ado, let's go into this. The first concept that we need to understand is what are averages. So an average is essentially a number that expresses the central or typical value in a set of data. In particular, the mode, median, or most commonly, the mean, which is calculated by dividing the sum of values in the set by their number. So let's imagine a concentric circle, right? A set of concentric circles. That's what an average is. The average is a central point around which the data radiates out, but it tends towards that central point. So it shows a trend towards that centralized tendency, and the measure of this centralized tendency is what averages essentially are. So what does that mean though, centralized tendency is? So an average is an indication of the central tendency of the data, right? So that's what we found out. So it's an indication of around where you would find data values in that set in general. So it's an average of a list is the expression of the central value of a set of data. It's essentially the center of the circle or the concentric circles where the data radiates out, right? So that's what essentially an average is, or an average would be. It's a measure of the central tendency of the data. So usually you would find that around the average, most of the data values have similar values to the average, or most of the data values work out to be equidistant from the average in general. So that's essentially what the average would be. It would be a measure of the central tendency. We don't need to really memorize this concept so much. We don't need to remember the definition or anything, but it would be great if we could internalize this concept fundamentally to later understand and apply on different average problems in general, right? So let's go to the formulae to remember, which is generally the stuff that is applicable in your examinations. So the general formula, and this is a theoretically correct general formula. So this is something that you can apply to all average problems and you will generally get a solution and you will get an accurate solution. This is not a quick method. This is the fundamental formula for a solution of an average problem. An average is equal to the sum of all values that you have in a data set. So all of the data, all of the values that you have, you add them up and then you divide it by the total number of values. So the number of elements that you have in that problem, you essentially divide the sum by that. An expression in an equation would be x bar, which is the denotion of average, is equal to a1 plus a2 plus a3 plus a4 plus up to an, which is n elements you are adding up. And then that is divided by n, which is the number of elements that you have in the problem. Other formulae that are essentially derived from the general formula itself are the total sum of values, which you can find out simply by rearranging the formula, the general formula that has been given. The total number of values, you cross multiply it on the other side, you get that sum of values is equal to the average into the total number of values. So this is basically a rearrangement of the formula that you know. Even if you don't memorize it, even if you don't remember it, as long as you know the general formula, you will have no issues deriving this in like a second on an examination paper. And it's not difficult to remember either because again, you're just deriving it from the general formula itself. The second formula too is similar. It's just a rearrangement of the general formula. So the total number of values is essentially the sum of all values, or the total sum, divided by average. So it's essentially again and again what you're doing is rearranging the general formula to get different values for your problem, right? So the question, whatever the question demands, whatever value the problem wants, you're essentially rearranging the formula to give you that. The elements that you know, you are using them to get the element that you do not know. So basically you're solving an equation. These are the three variables that you have in an equation. Usually you're going to be given two of these values, or you're going to get two of these values from other information that you've been provided in the question, and then you would be asked to find out the third value. So that's the general trend of what averages would be. To solve a simple problem, we move to this problem, find the average of 2, 4, 6 and 8, right? It's a very basic problem. You can try solving it yourself. If so, pause the video right here and solve the problem yourself and see if your answer matches the solution and your steps have been executed correctly. There are essentially three steps to this problem. Step 1, you find out the sum of all the values. So you add the given values. S is equal to 2 plus 4 plus 6 plus 8 is 20. Step 2, you get the total number of values, which is n. N equals to 4 because you have 4 values here. Step 3, put it in the formula for averages. The general formula, x bar, which is average, equals to s, which is the sum, divided by n, which is the number of values, which is equal to 20 divided by 4, which works out to be 5. Thus, the average of 2, 4, 6 and 8 is 5, right? So that's the three steps. In the three steps, you are finding out the values of all the three variables, and then you can simply put it in the formula. This is a very general, very simplistic, very average problem for this particular topic. There are, however, as we noted in the first few seconds of this class, different methods to solving an average problem in general. Not all average problems, but a very specific type of average problem has another method that we can solve it by, called the method of allegation. So these are the different ways to calculate averages, and for this, however, we will take a problem to better understand why the method of allegation is needed at all if you have the general formula, and this general formula is essentially a foolproof way to get answers to the average problem itself. So we will take this particular problem, right? The average of marks obtained by 120 candidates in an examination is 35. So 120 candidates gave an examination, they got different marks. When the average was found, the average was found to be 35, right? You do not need to know the total marks, you do not need to know the passing marks, the failing marks, anything. All you need to know is 120 candidates gave the exam, the average of all the different marks that they obtained is 35. So then, if the average of marks of past candidates, or the candidates who passed, is 39, which means if you take all of the past candidates and you tally their marks and you find the average of that value by putting in the general formula and everything, you will get the value as 39. And that of the failed candidates is 15. So again, if you take all of the failed candidates and you tally the marks that they got and then you find out the average of that, you'll essentially get 15. So what does the problem want you to find out? The problem wants you to find out what the number of candidates who passed the examination is, right? So the number of past candidates whose average is 39, that's what you essentially have to find. You can solve this quite easily actually by the normal method, right? So here's how you solve it with the normal method, right? You have about 15 steps to this problem. The steps, however, are pretty basic and pretty foolproof, and unless you have calculation errors, your chances of going wrong here are practically non-existent. So here's how the normal method works out, right? You have the steps on screen. So the total number of candidates, which is 120, the average of the total number of candidates marks they obtained is 35. Therefore, the total marks obtained by all of the candidates, which is essentially the sum of all values, is 120 into 35, which is 4200. This is again putting it into one of those derivations of the general formula, how to find sum of all values. So the number of students who passed, let us assume the number of students who passed to be x. X is a variable, x can take any value that we will give it during the entire problem. So the average marks that these people got, the students who passed got, the x number of students got is 39. So the total marks obtained by all of the students who passed, all of the passing students, is essentially 39 into x, which is basically the same formula that you're putting it in, right? So again, the average marks of failed students is 15. which you have it in the problem, the number of failed students is 120 minus x, because you will either pass an exam or you fail in an exam. There's no in between. So if you didn't pass, you failed. So since x number of students passed, the rest of the students must have failed. The number of failed students, therefore, would be the number of students who didn't pass, which is 120, minus the number of students who passed, which is 120 minus x, right? So the total number of students is 120, therefore the number of failed students is 120 minus x. Therefore, the total marks obtained by the failed students, again putting it in the sum of all values formula, is 15 into 120 minus x, which works out to be 1800 or 1800 minus 15x. So that's the value that you get, which is the total marks that are obtained by the failed students. Now what do we do? We add up the marks that were obtained by the passed students in total and the failed students in total. So we get the total marks that was obtained by everyone in that examination, right? So we put it in the formula, we add the two equations that we got, 39x plus 1800 minus 15x, that works out to be 24x plus 1800. So that's the total marks that anyone got. But we did derive a value of the total mark back in step 3. So we equate this equation that we got, this expression that we got, to 4200, right? And then we solve this for x. The value of x that we get is 100. The equations is solved in the presentation itself. So on steps 12, 13 and 14, you have the solution to the equation. If you just generally solve it as you would a linear equation, you get x equals to 100. Therefore, the number of passed students is 100. We're done with the problem. 100 is the correct answer. We've gotten the correct answer. This is a foolproof method. There is nothing that we could do wrong here unless we did a calculation error, right? So what is the problem with this method? The problem with this method is that it requires 15 steps. This is a very long method. Even if you internalize a lot of these steps, and you will internalize a lot of these steps more you practice, you will essentially do this in your mind. The calculation that you're doing is kind of big. The multiplications that you're doing is kind of big. The solutions that you have to find out, the equations that you're solving, those are kind of big. The general problem in general, to work through all of those steps, you have to spend a bit more time. So we need an alternative method to this. That alternative method is the method of allegation. What is the method of allegation? So the method of allegations is an alternative method where you find out the ratio between the two components, right? The pass and the fail. So that's essentially what you have to do in this problem. So for the method of allegation, the steps are: step 1, subtract the average from the higher value that is given. So like 39, where you have it, right? 39 minus 35, that is what you're going to do. Step 2, and this is the most important step, and even if you do away with step 1, you have to do step 2. So step 2 is the only thing that you can do, right? If you do step 2, you will essentially be doing step 1 and the same thing for the other value as well. So calculate the ratio for the absolute difference between the average of one component with the net average. So what does this part in italics represent, right? The absolute difference between the average of one component with the net average. So one component, which in the problem's case would be, say, the students passed. The number of students that have passed have gotten an average of 39. The number of students in total generally have gotten an average of 35 marks. So that is essentially what you're going to do for the difference of this section. And you're going to do the same thing for the other component in the second half in italics, right? When I mean the absolute difference, remember, I mean the absolute difference in that you should only take the numerical value and not the sign, right? So even if the answer that you're getting comes as negative, put a modulus around it, take the absolute value of it, take only the numerical value, not the sign in this case. A negative value will be converted into a positive value in that case. So when you have this ratio, you're going to consider the first component that you found the absolute difference of, or the first set in italics, be y, and the other one or the second one be x, right? So step 4, x is to y, or the ratio between x and y is the ratio that you're going to find in step 2, right? So what we have to remember for the method of allegations is that in the final solution, the method essentially gets flipped. So when you're finding out the difference in the averages for a component you call x, if that is what you put in the numerator in your step 2 calculations, then in your step 4 replacement in the ratio, that component x is going to go in the denominator. So whatever's on top on your right hand side is essentially going to be the component that's going to be on your bottom in the left hand side. So it's going to be flipped, it's going to be reversed, and that is the only thing that you need to remember, and this is a very important thing that you need to remember for allegations in general. If you get this wrong, you're going to get the problem wrong. So remember this, it always gets flipped. The components always get flipped when you do your final calculation for the ratio, right? When you do your replacement for the ratio, flip the components. So the steps for the actual problem. Let the number of students with average 39 be x. Let the number of students with average 15 be y. The net average, as we know, is 35 for all of the students. So x is to y is total average minus average of y, the mod or the absolute value of that. So even if we get a negative, we do not take the negative, divided by the total average minus average of x. Right? Even here we find the absolute difference, which means you put a mod around it, the negative values you do not consider. Again, notice that x in the numerator means on the other side x in the denominator. So remember this flipping. I am saying this repeatedly because this is the most important part that you need to remember in the method of allegations. This is what a lot of people might get wrong when you're in a hurry. Internalize this, that this is going to be flipped, right? So that's your ratio. Therefore, x is to y equals to mod of 35 minus 15 divided by mod of 35 minus 39, which works out to be 20:4, taking away the negative signs and everything, which works out to be a ratio of 5:1. So the number of people who passed to the number of people who failed, the ratio for that is 5:1. So you're finding essentially the number of people who are giving the average of the first component is to the number of people who are giving the average of the second component, right? So that's what you're doing. This ratio is the ratio between the total number of values for your second component is to the total number of values for your first component. Again, the order gets flipped, but you basically get the picture. It's the total number of values that you're getting the ratio for. And that is exactly what the problem wants us to do. So solving for x with ratio proportion is 5 out of 5 plus 1, which is 6, multiplied by 120, which is the total value, which works out to be 100, right? So we get the same answer from this method, except here we have a lot less steps. The only step that you actually need to work out is step 4 and 5, which will take you about a few seconds. The calculations, as you note here, are much smaller. They are much less unwieldy. They are much less multiplication based, they are much less labor intensive, right? So the method of allegation helps you in this way. It essentially quickens the process for you. It essentially helps you solve this particular type of problems really easily. However, there are certain requirements for the method of allegation. The first requirement is that one must have the total number of values given. For example, in this problem, we had the value of the total number of values given, right? We knew that 120 students in total had given the examination. So we need that for the method of allegation to do that final calculation at the end where we apply the ratio to the total number of values. So to find the percentage or essentially the ratio out of the total number of values, the fraction out of the total number of values that that component actually represents, we need the total number of values to be given to us. If the problem doesn't give it, the method of allegation is probably not going to work unless you can derive the total number of values from some other step or something, right? The second is that one must have the general average, the value of 35 that we have, the second value that we're subtracting, that is something that we must have. So when we have the general average, we can essentially solve for this problem easier, right? That is essentially what we are going to do with the general average. The third is that one must have two components, here the passing and the failing, each of which have a definite average given and which add up essentially to the total quantity. Right? So we have a component x, a component y. The total number of quantities is always going to be x plus y. We cannot have a third component, we cannot have two components that do not add up to the total, right? So that's essentially the requirements for allegations in general. You can have different situations where you may be given the number of values for x and y, and then you are not given one of these variables that I'm pointing out here as requirements. So essentially there are four things that will go into this problem. 1, total number of values. 2, general average. 3, the averages of each of the individual components. The components will have to add up to the total quantity. This is a requirement that will never be not fulfilled in a case where you will apply allegations. And the fourth thing is that the number of values of each of these components, right? So these are the four things that you need to know. So any three things of these have to be given. For this particular problem, these are the three things that have to be given when you're finding out the value. The values are given, something else might not be given, and then you will reverse engineer the formula that you learned in allegation generally. You will rearrange it like we rearrange the formula for averages, and you can find a solution pretty easily, right? So that's the method of allegation, and that's it for today. That's all for this video. Thank you so much for watching. I will see you in the next problem where we address other issues on averages in general.